Let's take a look at some combination problems involving a deck of cards and watch how these problems can get very tricky very quickly. First up, nothing too difficult here. I want to know how many different ways I can be dealt 5 cards from a deck of 52 cards. So I know this problem is a combination because the order of the cards doesn't matter. I'm allowed to mix up the cards as soon as they're dealt to me, so that's what makes a combination a combination. The order does not matter. And so this first question is fairly simple to answer. I've got 52 cards that I could possibly receive. And I want to know how many ways I can be dealt 5 of them. So 52C5. Remember, find that NCR button on your calculator to help answer this. So that gets me a total different number of possible hands I could be dealt. 2,598,960. And you guys can confirm that on your calculator. Okay, nothing too difficult there. But watch this next question. This next question says, how many hands, 5-card hands, are possible that have at least 3 face cards in them? Well, if you watch the last video, you know that the at least problems can be a little bit tricky. This one's even trickier than that one. Being dealt at least 3 face cards means I could be dealt 3 face cards, or I could be dealt 4 face cards, or I could be dealt all 5 face cards. Face cards being jacks, queens, and kings, if you're not familiar. And so we may remember from that last video that, okay, well, I'm adding these ors together. So I'm adding the different ways I get 3 cards, or 4 cards, or 5 cards together. Well, that's good, but there's one more part to this problem, because remember, no matter what, we're still being dealt 5 cards. And so if I get just 3 face cards, that means I also get 2 other non-face cards. So I've got another part of this. I'm just going to say 2 others. So if I'm dealt 3 face cards, that means I also have 2 others. If I'm dealt 4 face cards, that means I have so there's a multiply in this too, 1 other non-face card. And if I've dealt all 5 face cards, that means I have no other non-face cards in there. So putting all this together, let's see if we can piece this. I told you these ones get really tricky really quickly. Let's start with our 3 face card possibility. Well, in a deck of cards, there are 12 face cards. There's the jack, king, and queen of each suit, and you can see that on that table on the side. So the way to get 3 face cards is I've got 12 to pick from. I want to know what happens if I get 3 of them. Okay, we might as well finish out the orange part of this. To get 4 face cards, that's going to be 12C4. And then to get 5 face cards, that's 12C5. Well, let's deal with the red part of this as well, the and the other part. And so I have to think, well, the others are the non-face cards. If there are 12 face cards in the deck, that means there are 40 non-face cards, because there's 52 cards in a deck. So this would be 40C2. And those pieces are being multiplied together. So there's sort of, I'll kind of bracket this off. There's the different way I can get 3 face cards and 2 other cards. In addition to that, I told you this one's tough, I can get 4 face cards. And once again, that would mean 1 other card. So of the 40 non-face cards, I want 1 of them. And then finally, the other or possibility was to be dealt all 5 face cards, which meant there were, of the 40 non-face cards, I did not get any of them. Whew, isn't that fun stuff? Using a calculator to work out all these individual pieces, let's see, I'll just go ahead and write these numbers down. You can pause, actually, you know what, why don't you guys work this part? I'm going to pause the video so this part can pop up really quickly, and then we'll get our final answer in just a moment. And so there are the different numbers I ended up with. I color coordinated them so you could check your work. Multiplying all those individual pieces together and then adding the red and orange parts, I came up with a final different way of the number of ways of getting dealt at least 3 face cards to be 192,192. Yikes. Let's go ahead and take a look at one more that's going to hopefully be a little bit easier than that. This last one, it's that at least at most it's going to get us. In this last one, we want to get exactly 3 jacks, and there's our keyword telling us to multiply 2 other cards that aren't jacks. And so this one won't be as difficult. Let's start with the number of ways to get 3 jacks. Well, once again, we want to know how many jacks are in a deck. There's 12. There's 4 jacks in a deck, and I want to get dealt 3 of them. So 4C3 is the number of ways to get dealt 3 jacks. And it tells me to multiply, because I want both of these to happen, 2 other cards that are not jacks. Well, if there's 4 cards that are jacks, that means there are 48 cards that are not jacks, and I want to end up with 2 of those. So multiplying these 2 individual parts together, or actually I guess calculating these first on my calculator, there's 4 ways to get dealt 3 jacks. And there are 1,128 ways to get dealt 2 cards that are not jacks. Multiplying those 2 pieces together gets me a total of 4,512 different ways to get 3 jacks and 2 non-jacks.